So like the original title of my talk was like some bullshit about vendor abstraction, which I realized I didn't really care that much about. So I'm talking about something that's very related, but isn't exactly, so I misled you, and I'm sorry. But I'm going to be talking about hardware engineering in kind of like, or modern hardware engineering, I guess is the best way to describe it. I guess before we do that, I work at DigitalOcean. I manage the platform and systems teams, so everything from basically like hardware design and hardware engineering up to like things in user space. I used to work at Red Hat and Venmo and had the incredible misfortune of maintaining Puppet 2.7, and I work on a bunch of open source stuff. So yeah, that's a little bit about me. But really, like this is my job. So I'm going to be talking a little bit about hardware stuff, but I'll also, throw in some color with the operating system hatred. So I guess before we get started, we can talk a little bit about why this is a problem that we care about. So like DigitalOcean, if you're not familiar, is a cloud provider. We're a fairly large public cloud. Bloomberg actually just like wrote an article using the unit of hundreds of millions of gigabytes, which just like cool. But basically, we see a lot of these problems, right? So hardware lifecycle management is a really difficult set of issues. Mostly, well, everything comes down to vendors, but flexible and burst workloads are prevalent, right? So we want to like be able to manage hardware in the same way that we manage a cloud instance somewhere. And vendors are just the worst. So I have actually almost nothing good to say about any vendor. So that will be prevalent throughout the talk. So I hope you didn't come here for like cheery vendor talk. But basically, I think vendors introduce a lot of problems, and we notice this at DigitalOcean. We obviously have vendors because we buy hardware, but this is basically going to be mostly about our journey away from a lot of hardware components that we replace with software. And one of the reasons to do this, there's a whole lot of reasons which I'll talk about, but the provisioning process is a huge one. So provisioning hardware is traditionally this incredibly painful process, right? So like you have this requisition thing, and you have like all of these processes to order the hardware from the vendor, and to put the hardware somewhere, and to do something with it. And like it's just a whole bunch of annoying stuff. And the provisioning process is incredibly painful on hardware. But the reason for this is actually that like vendors actually intentionally make it difficult to sell their thing, right? So like all these different vendors all have their different hardware management platforms, none of which work. And that like there's no reason that BIOS management is as difficult as we make it. There's no reason that firmware management is as difficult as we make it. And I'll tell some stories about this in a sec. But basically, at a high level, the provisioning process is incredibly painful with hardware components, right? So like the components that I'm mostly going to talk about are hardware RAID controllers. Don't work. I was going to talk about SSDs because like the SSD vendors are real bad, but decided to spare you that kind of sadness. And I'll also talk about how we've moved a lot of the things on that were previously on networking devices into software running on hosts, right? So that's kind of the high-level overview, but I think the provisioning process is actually a big thing. So one of the, how many of you have ever used Mega CLI? How many of you have ever liked using Mega CLI? Ben, get out. Basically, like Mega CLI is a torture device built by LSI, but I've told them that, so they know. But I think Mega CLI makes the hardware provisioning process even more difficult because if you need to change RAID sets, you often have to do it via like this weird RAID BIOS that doesn't always work correctly, or you have to boot into like a RAM disk and then do reconfiguration, or you have to like do all of these different things that involve just like pure pain. And so the provisioning process is difficult. I'll talk more about the actual ins and outs of how we handle software-rated DigitalOcean, but one of the nicest things is that the provisioning process is entirely reliant upon software, so we can actually just use, we run a Debian variant, I guess you could call it, that we basically just pre-seed install everything, and then we get to reconfigure it whenever we want, right? So I'll talk more about what this looks like in practice and actually some of the problems with it a little bit later, but this makes setting up RAID really easy. So firmware customization and BIOS compliance. So like one of the things that is interesting about the way people handle BIOS is that like no one serializes their BIOS specification, which like is kind of important, right? If the vendor sells you out of order boot devices, you're kind of fucked. So this is actually something that I don't have a great answer for because BIOS is so specific to the vendor, first of all, and second of all, no one's really been able to implement kind of large-scale, general, like early bootloader support. I mean, there's Core Boot and there's some other tools, but Core Boot, for example, requires you to know how to solder, which is just like bad step 0, and there's nothing else. So yeah. But like the BIOS and like firmware and bootloader problems are just like incomprehensibly complicated. We actually have some tools at DO that we might open source, we'll probably open source, that allow you to live edit registers on a running machine. So that's how we've done a lot of BIOS customization, is by just changing MSRs on top of running machines. I think Intel has something similar. So this is another one of the issues. Device initialization is just like don't. Talking about firmware, the firmware that a lot of these devices rely upon is shady, basically. Actually, one of my favorite vendor stories is when Huawei copied a bunch of firmware to the wrong FTP server and like made all their firmware public for a little while, which like dope. So the device initialization problem is tied very heavily to the bootloader issues. I'll talk about some of the solutions of these. A lot of these are just fucked, so I don't know what to tell you. But device initialization is hard. And then like drivers, oh my God. There's a reason that a lot of the large providers are writing their own drivers, and it's because the vendors have no idea how to write drivers. We had, I can't actually name this company, but we had a large low latency NIC vendor with a bug in their driver that would cause slab corruption, which is like not that cool. And they actually like told us that we should disable the console on our server to fix slab corruption. Vendors are dope. Just don't. And then like installation and post is actually like the nicest part. Like writing pre-seed is torture, but like it's better than having to do whatever you need to do. And then post, which is just like initialization after installation, right? So these are the kinds of high-level problems. Most of them are intractable, so good luck. But I think it's worth pointing like the full set of them out because the solutions often involve kind of sidestepping a lot of these limitations. And for what it's worth, like I'll talk more about software RAID, but like software RAID doesn't actually solve the low controller firmware quality problem, right? Because we still have the issue of we still need some storage controller, right? Like we don't want just like raw SATA devices plugged into like the motherboard because we need device ordering and we need all these other things that we can't get with just pure, with kind of just like pure SATA. So we still have device controllers, but like minimizing their impact and minimizing what they do to the kind of fullest extent, I think is something that is worthwhile. So we talked about this, but like the stuff that's wrong with third-party components is basically they're super expensive, right? So like good RAID controllers are actually really, really expensive. Bad ones are really, really cheap. Like most things, like you get what you pay for, right? So like the best is like there's a large hardware vendor that will sell, like by default, will sell you an LSI controller with no write-back caching. Like why? And there's just a lot of stuff there where like good RAID controllers are like $300 to $500 MSRP, and you actually don't need them at all. I'll talk more about the transition to software RAID, but there's a huge amount of just bullshit involved in RAID in particular. And then vendor-specific firmware bugs where like there's a vendor that you know, kind of had some problems with their storage controllers. Again, like storage makes me really angry, but their storage controllers wouldn't be able to find disks that were plugged into them. So like what? Seems like kind of basic, but could be wrong. So moving hardware into software. So I'll just talk about the kind of 3 areas, and I'm going to focus on the first 2. So the first one is like guest switching, flow control, and QoS, which is very specific to running a public cloud. And then RAID management, which I think is a lot more generic. And then a little bit about device tuning at the end, and kind of like tuning at the OS level, and a lot of the things that this has brought. Yeah, so we kind of went through this, but like it's worth saying, like I'm advocating for getting rid of like hardware switching in a lot of cases, although you obviously need some of it. But like the complexities of hardware switching, vendors are still going to be around, right? And CPU and memory is cheap, which is like a huge amount of the reasons that we have RAID controllers, a huge amount of the reasons that we've done offload onto NICs, for example, is because hardware was expensive at some point, and it's not anymore, right? It's not expensive at all, especially CPU and memory. Like people often use the fact that software RAID uses more memory to do rebuilds and things like that as an excuse to not use software RAID, but it's like I can go and buy a 32 gig DIMM for like $80 MSRP. Who gives a shit? So that's that. So switching, flow control, and QoS. So we do this at DigitalOcean with Open vSwitch. If you haven't used Open vSwitch, it's actually pretty good software, which is like high praise. And we're doing close to 40G line rate consistently on top of Open vSwitch, right? So you have a guest, you add that guest's virtual interface into a flow, and then you can do configuration on that. And like, this is one of those things that is like you could not build a lot of this stuff, at least at layer 2, you can't build a lot of the stuff that we require with just kind of hardware, because like, for example, you can't have more than 4096 VLANs. So if you're doing this stuff purely at L2, there's just tons of issues with doing it on hardware. Not to mention the fact like that vendors introduce entirely arbitrary limits on things like ARP table sizes, route table sizes, and like they'll make you pay to get bigger route tables, which like what? Again, like that's a memory problem that you can easily solve. And then the other thing that's hugely beneficial, which is also a big advantage of using software RAID, is like the high rate of flow configuration. So like you can do flow alteration on the fly. You can do all these different things that you would probably want to do if you had a very flexible system. And like this is not a particularly resource-intensive thing to do on every hypervisor, right? So we have tens of thousands of machines, and every hypervisor has all of these different bits of configuration and can do this kind of on-the-fly flow control, QoS, and like virtual switching stuff. So I'll talk a little bit more about disk stuff than about networking, because I think this part of the kind of like system is a little further along. So we talked a little bit about the issues that come with RAID, but there's a lot of questions that you want to ask, especially if you're running SSDs. So like we run exclusively on SSDs, and the kinds of questions you need to be able to answer to figure out the number of erasures that exist, like NAND durability questions, questions around like why, especially in certain RAID configurations, like why does this device have like 3,000 erasures and this device has 210? And like there's no way to answer that with a hardware RAID controller because you just can't see what's going on unless you convince a vendor to give you kind of custom firmware, or you have some kind of more robust way to get that information. So getting the information that you need to find out about hardware health is incredibly difficult with hardware RAID. The other major issue, again, like if you're on SSDs, is the lack of trim support through RAID controllers. So if you're familiar with how kind of SSD, like NAND works, I'll talk about two-dimensional NAND, but you need to clear blocks that have data written to them that are no longer in use, because otherwise you run into NAND durability problems. And you also get extremely slow writes because you have to actually flash the cell that you're then about to write to, which just means that every operation takes so much longer than it needs to. And then also being able to answer the question of like which disks will these blocks get written to when I do something about them, right? So like we can even answer questions like when this page gets M-advised in this way and we do something with it and we end up kind of like LRUing it out, which device will it end up onto? And so those kinds of questions are really important to answer, especially in SSD land where NAND is actually very fragile. And a lot of companies kind of buy SSDs and say, oh, we have SSDs now, we can do whatever we want. They're really fast and we can treat them however we want. But they have pretty significant like lifetime limitations and other things you have to monitor very closely. Otherwise, you end up in nasty situations. So as I mentioned before, one of the nicest things about running software RAID is that you can like completely change the way that your RAID configuration works just by specifying, hey, my MD RAID configuration now looks like this. You no longer, like, we used to have a lot of expect scripts, which like, I like TCL, but no. We used to have a lot of expect scripts that knew how to reprogram RAID controllers. And I think this is a fairly common thing. But maybe I just have done it, like, because I've used it other places, but maybe it was just me, so I don't know. But the, like, not having to touch a BIOS, like something early in the boot cycle to fix problems with RAID, or just change RAID, right? So like if you want to switch from RAID 5 to RAID 10, you just reinstall the machine. And MD RAID has had some bugs. There's actually were some interesting bugs recently that were more controller, that were more like drive controller firmware bugs, but they kind of got blamed on MD RAID because of how it interacted with the drive controllers. But like if you run certain Intel SSDs and certain Samsung SSDs, there was a nice little off by one, which would lose data. And MD RAID is completely ready for production. The performance stuff is incredibly good compared to hardware RAID. So the memory utilization is definitely higher, but again, memory is super cheap. And you can also, like, you get every kind of knob that you need in order to change the way that the memory gets utilized, right? So you can tune the stripe cache size, which changes the stripe size, which causes, like, we've seen with tweaking while being moderately considerate of memory, you know, we've seen this basically double software RAID performance. And I've heard of people who have more than doubled software RAID performance based on tuning this, but there's also issues. The default is 512, so it's 512 4K blocks. That's the default block size on Linux. Then there's Flash Cache and Enhance IO, which Enhance IO is a fork of Flash Cache, and Flash Cache is actually intended for, it was released by Facebook as part of one of their engineers' PhD theses, where you use a flash, well, you use an SSD in the case of flash cache, but you use flash storage to basically act as a write-back cache to spinning storage or centralized storage, right? So this is another thing, and I'll talk more about this in a bit, but the stuff that's happening in the storage community, particularly around non-volatile memory over PCIe, is incredibly exciting and cool. And so, like, people who are talking about how SATA is too slow and they want to do something about it, and there's a lot of really cool stuff. Intel is unsurprisingly driving a lot of this work, but they're working on a system called Crosspoint, and NVMe is widely available. It's non-volatile memory over PCIe, so you use PCIe slots. I think another hardware trend is that we'll see a lot more PCIe slots in machines. It's a fast, useful bus, and we'll see a lot more of that, I think, but NVMe is super interesting. Then finally, DM cache, which is exclusively for device mapper, which is a piece of Linux tooling around device management, is now in the mainline kernel. It has been for a little while, and it has a similar idea to flash cache, where you basically use flash storage as a write-back device. So with the same RAID configuration and the same disks, we see about 3.5x performance increases using software RAID without changing durability. You also get the kind of full range of like ATA commands that you want to send through. So you aren't able to fully utilize like the ATA command set through a hardware RAID controller. And then glorious, glorious trim, where we can actually treat SSDs correctly and take care of them as required. I guess the biggest kind of emergent trends in like the software RAID space is like, well, I don't have high hopes for ButterFS, but ZFS and Windows Server both now like recommend using software RAID, right? So they would rather not run the software behind a RAID controller. I think when Windows Server 2012 is like, you should do this, it's probably like time if you're not already doing it. Also, notice how they can't just fucking call it software RAID. It's called software storage control. Anyways, shout out to Windows. ButterFS, I would not care about. Doesn't matter. Anyways, like the takeaway is like, have you ever tried to debug a RAID controller and made it through? It's basically impossible. Mega CLI is dead. Like things are getting cheaper. Don't waste time kind of moving your stack into software. There's not a lot of reason to keep heavy components around, especially RAID controllers and kind of like overly intelligent NICs. CPUs and memory will keep being cheaper, although I think the rate of them being cheaper is kind of dropping based on, I guess, kind of trends since 2010. Like the kind of like logarithmic improvements that we've seen are no longer happening. Yeah. Does anyone have any questions? Yeah. So the question was, on this slide, there was, they call it Crosspoint, just to be confusing, but it's a non-volatile memory alternative. Well, it's an NVMe, but it's not exactly. That's about 100 times faster than DDR4 that Intel's producing with Micron right now. So it's like 1,000x faster than writing to flash, and it's really promising. I'm supposed to get some engineering samples of it pretty soon, like I think beginning of 2016, and they're shipping it in middle of 2016. So like it's very much around, and it's like NVMe is generally available. Like once you can buy something on Newegg, you're good. That's where I get all my server components from. But yeah, there's some really interesting stuff happening in the non-volatile memory space. NVDIMM has been around for a while, but now there's a lot of non-volatile like kind of alternatives, especially like the bus problem is becoming increasingly interesting because like the NVMe folks said that SATA is too slow and they can't even use SAS. So I think we'll see some cool interconnect stuff happening over the next few years too. Any other questions? Yeah.
2 questions. Why do you hate ButterFS? And there's an API, lib storage management. I wasn't sure if you have used it. It's sort of meant to be some sort of abstraction to dealing with that sort of crap. If
yeah.
you have to.
I haven't used it. Haven't had like a huge need to use it. Why do I hate ButterFS? It's really shitty. Like it has like really severe bugs in it. Actually, so I forget what this company is called. There was a company that's based in Europe that does kind of like infrastructure hosting, and they were running ButterFS, which I actually blame on them, like it's their own fault. But they were running ButterFS, and ButterFS has hundreds of metadata balancing bugs where the information that it thinks it knows about block accounting is not correct. So this company actually had the ButterFS file systems backing their Ceph cluster fill up completely because ButterFS's internal counters thought that there were there was 55% utilization and there was actually 100% utilization across the cluster. So they ended up losing a bunch of data because they couldn't like get Ceph working, which is not Ceph's fault at all. It's completely ButterFS's fault. And I just think, and I recognize that building file systems is quite difficult, so I don't fault them for it, but I don't know of anyone who doesn't regret ButterFS. And people boast about how Facebook's running ButterFS, but they're running it on their stateless like application tiers. They're running it places it doesn't matter. And they're running XFS and ext4 basically everywhere else. So I don't think that kind of like file system maturity is a long game, but it's not the kind of thing that like you want to mess around with. Like when your file system makes a mistake, you lose data. And like maybe it's fine to run on a home computer, but like we don't lose data, right? It's like the biggest no-no ever is losing data. Any other questions? All right, thanks for coming.